quadrilateral is any four-sided figure. It doesn't matter what it looks like, as long as it's closed. It's any four-sided figure is a quadrilateral. If they tell you it's a quadrilateral, the only thing you can assume is that all of the angles add up to 360. Kind of like a circle. All of the angles, all four angles, total 360 degrees. Okay? And so in this first example, you have to find the measure of angle Q and the measure of angle R. Now, we're going to talk about parallelograms in a little bit. Parallelograms is a special quadrilateral. Those parallelograms have special rules. If they don't tell you it's a parallelogram, then the only thing that you know is that all the angles add up to 360. That's it. Okay? And so in this first example, we have to find the measure of angle Q and measure of angle R. So any ideas on how we do that? Add them all up and set it equal to 360, right? And then solve for X, and then go back and plug it into the angles that you need to find. Okay? And so we have 80 plus 70 plus 2X plus X equals 360. So then we have, right, 3X plus 150 equals 360. We subtract 150 from both sides. And you get 3X equals 210. Divide by 3 and you get X equals 70. Now, X equals 70. We have to go find the measure of those missing angles. So angle Q is X, which is 70 degrees. Angle R is 2X, which is 2 times 70, so that's 140 degrees. All right, any questions? Okay, y'all work the next one. Okay, so we know we have to add them all up and set them equal to 360. So, 82 plus 25x minus 2 plus 20x minus 1 plus 25x plus 1 equals 360. So when you combine all your like terms, you should get 70x plus 80 equals 360. Yeah? Okay. Subtract 80 from both sides. And we get 70x equals 280. Yes? Divide by 70, and you get x equals 4. X equals 4. So now to find all the angles, how about if I name these, A, B, C, D, so that I know what we're talking about. A, B, C, D. So we know angle A is 82, they gave it to us. Angle B is, we got to plug in 4, so 25 times 4 minus 2, which is 98 degrees. Angle C is 20 times 4 minus 1, which is 79 degrees. Yes? All right. And angle D is 25 times 4 plus 1, which is, very good, 101 degrees. Any questions? Okay, now, there are 5 special properties of parallelograms. A parallelogram is a quadrilateral, because it has 4 sides, but it's a special quadrilateral. There are 5 important properties. These 5 properties are what you're going to use to set up your equations. These 5 properties are what you're going to use to set up your equations. So you need to know these. property number 1, opposite sides are parallel. Opposite sides are parallel. So, on your parallelogram, God bless you. On your parallelogram, you'll see the little triangles. That means the top side is parallel to the bottom side. And then the left and right sides are also parallel to each other. Now, when we start talking about parallel lines, that should automatically make you think transversal. So when we start dealing with the angles inside those diagonals that are inside that parallelogram, those are transversal. Okay? And so there are certain things that are not part of the properties of parallelograms, but you need to recognize because those diagonals are transversal. If this is a transversal, then that of these two parallel lines, then that means that angle is congruent to that angle because they are alternate interior angles. Okay? That's not part of the properties of parallelograms. You should just be able to recognize that. Did everyone see that? Does everyone see that the diagonal is a transversal? Yes. Okay, good. All right. So, opposite sides are parallel. Okay? Both pairs of opposite sides are parallel. Next, opposite sides are congruent. If it's a parallelogram, then opposite sides are congruent, which means on your picture, put your hash marks for the opposite sides. That means this side and this side are congruent. If this is 25, the bottom's 25. If the left side is 15, the right side is 15. Okay? So if the left side is x minus 10 and the right side is 2x plus 3, you set those equal to each other because they're congruent. Okay? Opposite sides are congruent. That's property number 2. Property number 3. Opposite angles are congruent. The angles opposite each other are congruent. Now we talked about those alternate interior angles that the diagonals form, but the complete opposite angle is congruent. So this angle is congruent to that angle. Likewise, this angle is congruent to this angle. So, for example, if this angle here is 80 degrees, this angle here is 80 degrees, right? That's opposite angles. Now let me ask you this. If all the angles add up to 360 and opposite angles are congruent, what does that make these angles equal to in this example?
Well,
200 is the total. What's each angle equal to? 100. Does everyone see that? Okay, so these two are 80, right? If you add that up, that gives you 160. Subtract that from 360, you get 200. Divided by 2, each angle has to be 100, right? Each angle has to be 100, which leads us to our next property. Consecutive angles are supplementary. They have to be. They have to be because of what you just showed me. Do you see that 80 plus 100 is 180?
yeah.
That's supplementary. 100 plus 80 is 100. Supplementary. Any two consecutive angles. Consecutive means in a row. Any two angles in a row are supplementary. Opposite angles are congruent. Consecutive angles are supplementary. So if they give you these two angles in terms of algebraic expressions, you would add them up and set them equal to 180. Okay? So property 3, opposite angles are congruent. Property 4, consecutive angles are supplementary. They have to be. Because the opposite angles are congruent, what's left, if you divide it by 2, any 2 angles in a row is going to add up to 180. Does that make sense? Okay. Logically, that's why I wanted you to come to that conclusion on your own, to see that. Okay? So far, our hash marks, we have opposite sides are parallel. We know that opposite sides are congruent. That's equal to this. This is equal to this. We know that opposite angles are congruent. This is equal to this, and that angle is equal to that angle. And we know that consecutive angles are supplementary. Okay? The last property is the diagonals bisect each other. Okay, that is not something that you would just automatically be able to logically see. But the diagonals bisect each other, which means they connect at the midpoint of each diagonal. So this is congruent to this, and this is congruent to that. Okay, now I'm actually going to put 3 hash marks and 4 hash marks, because I don't want to just put 2 hash marks here and for you to look at your notes and think that this is same as that. So you put the number of hash marks relates to the other segment that has the exact same number of hash marks. Okay. So the diagonals bisect each other. That is number 5. So opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, so all the opposites are congruent, right? Consecutive angles are supplementary, and the diagonals bisect each other. So if they're asking you to find the length of one of those diagonals, you need to know that the diagonals are cut in half. Okay? Now, there's a couple of other things that we looked at because it's transversal. We saw that this angle right here is congruent to this little angle right here because they're alternate interior angles, right? This angle is congruent to this angle because they're alternate interior angles, right? What about this angle and this angle? Why? What are they? They're vertical angles. This angle is congruent to that angle because they're vertical angles. Okay? What about what is this here? Okay? This angle plus that angle equals what? 180, because they form a straight line. So there's a lot of things that we already learned that you have to pull into this, okay? It's not difficult, though. Okay. Now, any questions so far? Okay. Now, they may give you a figure. This isn't actually on your homework, but you may see this. They may give you a a figure. And then they give you some information. And they say, based on that information, does that mean that it's a parallelogram? There are certain conditions. You don't have to meet all of these conditions for it to be a parallelogram. There are certain conditions that have to hold true in order for it to be a parallelogram. And that is what the next list is for. If you had to prove that a quadrilateral is a parallelogram, then you have to show that only one of these conditions are true. So you have to show that only one, just one of these have to be true. Not all of them, just one of them. If any one of these things are true, then yes, you can definitively say that it is a parallelogram. So first, if you show that both pairs of opposite sides are parallel, so if they say, if I have this parallelogram over here, A, B, C, D, if it tells me AB is parallel to CD, and AD is parallel to BC, Is that a parallelogram? Yes, because they gave me the information that both pairs of opposite sides are parallel. Then yep, it's a parallelogram. Okay? Or both pairs of opposite sides are congruent. So if they say AB is congruent to CD and AD is congruent to BC, is that a parallelogram? Yes, because both pairs of opposite sides are congruent, that automatically makes it a parallelogram. Or both pairs of opposite angles are congruent. So if they say angle D is congruent to angle B and angle A is congruent to angle C, is it a parallelogram? Yes. If both pairs, these are the key words here. Both pairs, both pairs, both pairs. So if both pairs of opposite sides are parallel, then it's a parallelogram. If both pairs of opposite sides are congruent, then it's a parallelogram. If both pairs of opposite angles are congruent, then it's a parallelogram. Now, number 4, only one pair. We're only looking at one pair. If one pair of opposite sides are both congruent and parallel, then it's a parallelogram. For example, if they show you this and they say, and they draw, so we know this is parallel to this, and it's congruent. That's enough information to prove that it's a parallelogram. So if they only give you information about one pair of opposite sides, they have to be both parallel and congruent to be enough information. Yes, because this is what you need to be able to prove that it's a parallelogram. So if both pairs are parallel, both pairs are congruent, or if both pairs of opposite angles are congruent, it's parallel. But if one pair is both parallel and congruent, then that's enough. And the last thing is if the diagonals bisect each other. I don't care what the sides are doing. I don't care what the angles are doing. If they show you that the diagonals bisect each other, it's automatically a parallelogram. Because they can't bisect each other without it being a parallelogram. Okay? Any questions? Yes. Okay, so let's look at a problem. Okay, I'm not going to erase this, but... Okay, so I'm going to put some hash marks on here, and we're going to figure out if it's enough information to show that that's a parallelogram. Just because it looks like it doesn't mean it is. Okay? Okay, so if I tell you that... Is that a parallelogram? Yes. Both pairs of opposite sides are congruent.
Yes.
No. Why not?
It's only one side.
Only one pair is congruent. That's not enough information.
Yes.
Yes. Y'all paying attention?
Oh yeah. Hold on. It's looking at the rules and you still got the wrong answer.
It has to be. What would have? What else? Let me name this. Okay. What other information will be needed to show that it's a parallelogram?
Another side of another
Angle A and C, if those were congruent, then it would be a parallelogram, right? Okay. Or if AB was congruent to CD, then it would be a parallelogram, right?
Wait, or if that was parallel, right?
Yes. Or if this was parallel to this, then it meets one pair is both congruent and parallel. So y'all seeing what I was talking about now with these conditions? Okay. That's all I want to get at. Okay, so let's look at some examples now. Okay. Okay. So, is that a parallelogram?
Yeah.
Yes, because the diagonals bisect each other. You understand now? Okay, let's look at these examples. Always start by reading the information they give you. They tell you FGHJ is a parallelogram, so we know it's a parallelogram. Okay? And it says find the unknown length. So we need to find JH. So JH. JH is 5 because opposite sides are congruent. JK. JK is what? Because the diagonals bisect each other. That's what it means by explain your reasoning. Because the diagonals bisect each other. Because opposite sides are congruent. Alright? Not really. I just want you to tell me out loud. Okay? Okay, look at number 2. They tell us it's a parallelogram. What's the measure of angle R? 70, because this is congruent to this. What about Q?
110.
No.
110.
110, why? Well, that's one reason, because all angles add up to 360, but you would have to know that consecutive angles are supplementary. So this is 110.